So I just saw this on Reddit, and I think it's a very interesting proof that -1 is equal to 1 by using integration by parts. And of course, we know that -1 is not equal to 1. So where is the error? First, we are going to start with the integral of e to the x times hyperbolic cosine of x. And then we end up with this equation, and let me just explain how they got that. So, with this right here, we are going to start off by integration by parts. I will just do the di, and then we will end up with a repeating case. So let me get the plus minus plus ready. We will be integrating e to the x. And then we will be differentiating cosh of x. Integrating e to the x, we just get e to the x. Do it again. Differentiate cosh of x, we get positive sinh of x. Do this again, we will end up with cosh of x. So as you can see, this is a repeat from the original, so we can stop right here. And then let's just go ahead and multiply this. That will be the first part of the answer, which is e to the x times cosh of x. And then this will be minus e to the x times sinh of x. And then lastly, we are going to multiply these two together and then put that inside of an integral. And this is a plus integral, and then we have e to the x times cosh of x. So that's how they got this right here. Now here's the deal. Notice we happen to have this integral on both sides. So if we just subtract them, of course this and that will cancel, and we'll just end up with 0, and that's equal to this right here. E to the x cosh of x minus e to the x sinh of x. Okay, factor out e to the x right here, and then multiply that with cosh of x minus sinh of x. Now, we know that e to the x is not equal to 0, so we can just divide both sides by e to the x. So that's legit, and then we'll just get 0 here, and that it means we have cosh of x minus sinh of x. Move this to the other side, so that means sinh of x has to be cosh of x. Now, we are going to use the exponential form for sinh of x and also cosh of x. This right here is equal to 1/2 e to the x minus e to the negative x. And that's equal to 1/2. This right here is just pretty much the same thing, but with a plus in between. Now we can get rid of the 1/2 on both sides, and notice we can also get rid of this and that on both sides, so that means this has to be the same as that. So from here, we end up with negative e to the negative x is equal to positive e to the negative x. And once again, e to the whatever power cannot be 0. Let's just go ahead and divide both sides by that. This and that cancel. We have -1 on the left, and then on the right hand side, they cancel as well, and we just get 1. -1 is equal to 1. Very cool, huh? And if you want to just add some spice to it, you can add 1 to both sides, and you can end up with 0 is equal to 2. Just as fun, right? But of course, this is not correct. Likewise, that's not correct. So where did this go wrong? Ready for the answer? Remember, we start off with an indefinite integral, so we should somehow end up with a plus c somewhere, right? But so far, do we ever use the plus c? No. Where is the plus c? Here's the deal. This is the integral. That's the integral. Technically, when we subtract them, this is not equal to 0. Here, this is technically a constant c, and that's where the mistake is. And in fact, we actually don't get 0. It's technically c over e to the x. So this right here is c e to the negative x. And now let's just kind of correct this from here. So this right here, we have c e to the negative x, and then this right here, cosh is 1/2 e to the x plus e to the negative x, and then minus sinh is 1/2 e to the x minus e to the negative x. Here, have a look. Half e to the x minus half e to the x is just gone. Then half e to the negative x minus minus becomes plus half e to the negative x. So we see c e to the negative x is equal to just 1 e to the negative x. So in fact, if you divide this on both sides, you can see that c is equal to 1. So when we end up with this right here, we will actually have to put a 1 on the left hand side and everything is legitimate. And now the question is, what's wrong with this? Well, unfortunately, it's just that integration by part, if we do it like this, it's not going to work. And the secret is that we didn't even need integration by parts for the integral of e to the x times cosh of x. So let me show you how to do it. So to integrate this right here, we are just going to replace cosh of x with 1/2 e to the x plus e to the negative x. And this works out really nicely, because first we can put a half in the front of the integral, and then distribute e to the x. E to the x times e to the x, we add the exponents, and that's still inside of the integral. We have e to the 2x. This times that, add the exponents, we get 0. E to the 0's power is 1. And then just go ahead and do it. Now, the integral of e to the 2x is e to the 2x, but we are going to divide it by the derivative of 2x, which is a 2. We can do this because the derivative of this right here is just a number. Technically, we are doing a u sub. Let u equal to 2x, and the derivative is just 2. And then to get dx is just du over 2, so that's why we have the 1/2. And then integral of 1 is just x. Not done yet, so I haven't put on the plus c. Distribute the 1/2. We have 1 over 4 e to the 2x, and then plus 1/2 x. At the very end, I will put on the plus c. And that'll be it.